All right, here's a diagram we saw last week. We call this a hanger diagram because uh, the hanger is balanced if both sides have the same weight. So in this hanger balance, we have a missing weight plus 3 pounds is balanced with 5 pounds. Now, what we can do to make this a simpler problem, although you may already figure out what uh, that weight has to be, is we start crossing off. This was Mr. Ojeda's little trick last week. You can start crossing off um, 1 pound from each side. Do that 2 more times, and you realize that what's left is the missing weight on one side and 2 pounds on the other. And since that's balanced, then we know the weight must be 2 pounds. And we know that's true because we took a pound off of this side, a pound off of this side at a time until all we were left with was that missing weight. Now, once we know that, it presents an interesting and useful little shortcut that we can use. Because when we have this hanger diagram, we'll go back to that same hanger diagram. We could actually write this as an equation. We did this last week. We could write this as x plus 3 equals 5 because the missing weight we don't know. We're going to use a variable called x. We know there's 3 more pounds with that, and when you put those together, it balances with 5 pounds. So we can picture this as two sides of the balance. That's why I draw that line there. And what we did is we took 3 pounds off of this side and we took 3 pounds off of this side. And because we did the same thing to both sides, it remained balanced. And what happened was when we did that, we got this missing weight is the same as 2 pounds. So in other words, that question mark must be 2 pounds, or you could say x is 2 pounds. Another way to write that is x equals 2, or x equals 2 pounds. Now this is useful, and therefore we call it the subtraction property of equality, meaning what? That you can subtract whatever you want from one side of a balance as long as you do it to the other side of the balance. Why do we do it? Well, usually it's used when you're trying to get that variable by itself. When do we do it? It's usually used when something extra is added on to the variable. So here's a much larger example that I would not want to have to spend the time crossing everything out. So if you wrote it as an equation, it would be x plus 10 equals 20. There's your missing number, and you have 10 more, and that must balance with 20. Well, there's your x plus 10 on one side, the 20 on the other. Well, what I can do is I can subtract 10 from this side, so all I'm left with is this missing amount. But if I take away 10 from this side to keep it balanced, I have to take away 10 from this side. And when you do that and you look over here, you're just left with the x must be 10. In other words, this is left and these 10 are left, meaning that question mark has to be worth 10. Now, it's also useful when you start dealing with decimals. You don't want to draw it out. Let's say you had an equation like this. You had some missing number plus 8.5 pounds must be 10 pounds. Well, I don't even need to draw that out because I know that I can just take away 8.5 pounds from this side, meaning I have to take away 8.5 pounds from this side, and I'm just left with x equals whatever 10 minus 8.5 is. If you ever needed to, use a calculator, or you know that's 8.5, or that's 1.5. What about this one? This one's a little different. You'll notice I tried to cross off one from both sides, but there was nothing on this side to cross off. So that kind of left me in a bit of a jam. So what did I do here? Well, for this one, since there was nothing to cross off, but there was 4 missing weights, I had to kind of split those up. So what I did was I said, well, this one goes with this one and a little bit of this one. This one goes with the rest of this one and this one. This one goes with this one and a little bit of this one. And this one goes with the rest. And if you look at that, I split each of these 4 evenly so that each one was about 1.5 pounds. So I had 4 different weights balanced with what I knew was 6. So I had to split those up, and it looks like each one was 1.5. So what does that tell me? Each question mark must weigh 1.5 pounds in order for me to get the 6 pounds total to balance. Well, if I don't want to draw this out, again, I could use an equation. Instead of saying 4 different x's, I could say x times 4 is 6. And what I did is I split it up. I divided it into 4 equal groups. And when I did that, I was left with each one weight was 6 divided by 4. And if I could put them on a calculator or just do that in my head, I know that's 1.5. So that means each X was 1.5 pounds. And that's a nicer way to do that than to draw it out. And that's using the division property of equality. What is the division property of equality? You can divide what you want from one side of the balance as long as you do it to the other. Why do we do it? Again, try to get that variable by itself. Try to find out what that variable must be. And when this is when we have something multiplied, the variable's multiplied. It's multiple variables on one side. So let's look at this one. Here you have a bunch of variables on one side. So we're going to use that division property. So what would that look like? Well, here I have 6 x's, 6 missing numbers, and it equals 6 pounds. So you might be able to figure out that each is 1, but using the division property of equality, I would divide this into 6 equal groups, divide this into 6 equal groups. 6 divided by 6 is 1, so each missing weight is 1. What about this one? Now this one I don't want to draw out, but since it's x times 20, I know that I have 20 missing numbers, and I have 60 pounds on the other. There's no x there, so I have 60 pounds. So I do the division property of equality, divide by 20 on this side, divide by 20 on this side. So both are split into 20 equal groups. And since I can do that, 60 divided by 20, x must be 3. So each of the missing weights must be 3 pounds. 3 times 20 is 60, so that works out. Now, what would I do here? Would I do division property or would I do subtraction property? Good, I would do subtraction property, right? Because there's something being added on to the x. So I would take away that extra 5 pounds from both sides, and I would get x is 5 pounds. What about this one? Would I use the division property or would I use the subtraction property? Yeah, I would use division property, right? Because I have 5 groups, right? The opposite of multiplication is division. So I'm going to undo that, split it into 5 equal groups, and get x is 10 divided by 5, or 2. Now, this is our little challenge one to end. What about this one? It looks like you have multiple missing numbers and some extra. What would you do here? Well, you would cross off these 3 like Mr. Ojeda did last week. Now that we have those gone, now we have multiple variables we can split into groups. That's like what Mr. Kinsey did last week. If I split those into groups like this, all of a sudden it looks like each has 1. So each of these missing numbers must have been 1. Well, how could I do that with the equation? Well, here's the equation. I have 5 groups of x plus 3 extra, and that's equal to 8. So I subtract that 3 from both sides to get rid of them. That's the Mr. Ojeda trick. So then I have just left with 5 groups of x's equal 5. Then I split those into 5 equal groups. X is 1. So we are going to use this language of the division property of equality and the subtraction property of equality as we get into more and more difficult problems.